All right, today we're going to decode one of the most foundational technologies of the big data revolution, Apache Hadoop. We're going to break down what it is, exactly why it was created, and how it completely changed the game for handling massive, and I mean massive, amounts of information. So let's kick things off with the problem Hadoop was built to solve, a problem of almost unbelievable scale.
To really get our heads around this, let's just think about this question for a second. Imagine all the data a company like Facebook generates every single minute. Photos, videos, status updates, likes, comments. We're talking about a constant tsunami of new data. You could have the most powerful supercomputer in the world, and it would just grind to a halt. It simply wasn't built for that kind of scale. And that exact challenge forced a whole new way of thinking.
And that, right there, leads us straight into our first section. The problem isn't just about having a lot of data. It's about what we now call big data. It's this challenge of scale, speed, and complexity that our old-school tools were just never, ever designed to handle.
So what is big data really? Well, it's not just about having a ton of it. It's about data that is so big, so complex, and growing so incredibly fast that our traditional tools, they just break. They literally cannot keep up with the demand. You know, to really wrap your head around the challenge, experts talk about the 4 V's. Volume, that's the obvious one, just sheer mountains of data. But then there's velocity. This data is streaming in at an incredible speed, 24/7. Variety is a huge one. It's a messy mix of all kinds of stuff, not just neat rows and columns. And finally, veracity, which reminds us that a lot of this data can be messy or inconsistent. So any real solution has to be able to tackle all 4 of these at the same time.
And this, right here, really gets to the heart of the whole shift. For decades, most of the data we dealt with was structured. You know, stuff that fits perfectly into a spreadsheet or a database. Easy. But now, the vast majority of the world's data is unstructured. Think about it. Emails, social media posts, photos, videos, sensor readings. You can't just drop a picture into a database row and ask it meaningful questions. This messy, wild, unstructured world needed a completely new kind of tool.
And that new tool, the big solution to this big data problem, is Hadoop. It represents a totally fundamental shift in how we think about storing and processing information when you're talking about massive scale.
So at its core, you can think of Hadoop as a framework for teamwork. Instead of spending a fortune on one gigantic, specialized supercomputer, Hadoop lets you string together a whole cluster of cheap, off-the-shelf computers. We're talking hundreds or even thousands of them, and gets them all working together on the same problem.
This quote is everything. It's the philosophical breakthrough that makes Hadoop so brilliant. See, in the old model, you'd have to pull terabytes of data from where it's stored across the network to a big, powerful server to process it. That just chokes the network and slows everything to a crawl. Hadoop completely flips that on its head. It says, hey, let's leave the data where it is, spread out across all those machines, and we'll send the computer program to the data. This simple idea minimizes network traffic and unlocks truly massive parallel processing. It's a game changer.
And when you put the two approaches side by side, the difference is just stark. Traditional systems, super expensive and notoriously difficult to scale up. With Hadoop, you just throw more cheap computers into the cluster. Need more power? Add more nodes. It's built to handle any kind of data you throw at it, and, this is key, it's built expecting failure. If one of those computers dies, the system doesn't even blink, because it already has copies of that data somewhere else.
Okay, so we've got the why behind Hadoop. It's powerful, it's scalable. But how does it actually pull this all off? Well, the magic really comes down to 2 core components that work together in perfect harmony. One part for storing the data, and another part for processing it.
Right. It's not one single piece of magic. The secret sauce is really a clever combination of 2 big ideas. A totally new kind of file system built for massive scale, and a new way to process all that data in parallel. So let's break each of those down.
First up, let's talk storage. That's HDFS, the Hadoop Distributed File System. Imagine you have a giant encyclopedia. HDFS takes that encyclopedia, rips it up into individual pages or blocks, and then scatters those pages across all the computers in the cluster. But, and this is the crucial part, it makes multiple copies of every single page and stores them on different machines. That way, if one computer goes offline, no data is ever lost. It's how Hadoop achieves both incredible scale and rock-solid reliability.
Now, for the brains of the operation, MapReduce. This is the programming model that actually processes all that data you've stored in HDFS. It works in 3 steps. First, the map phase.
The main job gets broken down into little pieces and sent out to each machine. Each machine then processes its own little chunk of data, all at the same time. Next, the shuffle phase cleverly gathers, sorts, and groups all those intermediate results. And finally, the reduce phase takes all that sorted data and combines it to produce the final answer. It's a really powerful divide-and-conquer strategy for computation.
Of course, when you've got hundreds of machines and tons of jobs all trying to run at once, you need a manager to keep things from turning into chaos. And that's where Yarn comes in. You can think of Yarn as the traffic cop or the operating system for the entire Hadoop cluster. It's in charge of scheduling tasks, handing out resources, and making sure everything runs smoothly without jobs tripping over each other.
But here's the thing. Hadoop didn't just stop with HDFS and MapReduce. Over time, it grew into this huge, sprawling ecosystem of different tools, where each tool is designed to solve a very specific problem in the big data world.
And this is really where Hadoop became a true platform. Because let's be honest, writing raw MapReduce code can be pretty complicated. So a whole team of other tools popped up to make life easier. Hive, for example, lets data analysts use the SQL they already know to query data. Spark came along as a faster, more flexible processing engine. HBase gives you a real-time database on top of HDFS. It's a whole toolkit that makes big data so much more accessible to so many more people.
So, what's the point of all this crazy technology? Why does any of this matter? Well, at the end of the day, the goal is simple: to turn all that raw, messy, complicated data into actual insights that can lead to smarter business decisions.
And this is not theoretical stuff. Look at these real-world examples. Companies are using Hadoop to build complex models that predict why a customer might be about to leave their service. Banks are using it to model their financial risk by pulling in data from hundreds of different sources. Retailers analyze every single transaction to figure out the perfect promotion. And telecom companies can actually predict when a piece of network equipment is about to fail by analyzing sensor data in real time. The applications are pretty much endless.
You know, when you step back, Hadoop's greatest legacy might be that it taught an entire generation of engineers and scientists to just think differently about problems. It proved that by distributing both our data and our computer programs, we could solve problems that were once considered completely impossible. It basically democratized the power of supercomputing. And that leaves us with a really fascinating question to think about. With this way of thinking now in our toolkit, what's the next impossible problem that we can solve?